Yeah, so let us start with first question. It is an easy question. So the first question is GATE 2011 electrical technical question 50 and 51. So RLC circuit with relevant data is given below. The supply is given to be 1 at an angle 0. The supply current is given root 2 at an angle pi by 4, which is 45 degrees. I would suggest people to turn off their mics if they are on. Pramod Shukla. Yeah, thank you. And the current through RL branch is root 2 at an angle minus 45 degrees, minus pi by 4. Okay, so the question asked is the power dissipated in resistor R is. And the second part of this question is the current through the capacitor is. So it's a mathematical question, basic electrical engineering in AC analysis. So for the power dissipated in the resistor, you just have to make the vectorial diagram of the power. So as power, it's calculated by Vs into IRL. As Vs is in parallel with the RL branch, so Vs into IRL, which is given. So 1 angle 0 into root 2 angle of minus pi by 4, which gives root 2 at an angle minus 45 degrees. And if you take the projection of that PRL into cos of phi, which is cos of minus pi by 4, which is 1 by root 2. So both will get cancelled, and the power through resistance in that RL branch is 1 watt. Okay, so active power, which is across the resistor, is the projection of the cosine angle of that apparent power PRL into cos phi. Okay, now the next part is the current through capacitor. It is simple from looking at this figure. IC is equal to supply current IS minus IRL. So IS minus IRL is the current through the capacitor. You just have to see it vectorially. So IS is given as root 2 at an angle pi by 4, and IRL is given as minus root 2 at an angle minus pi by 4. So even if you solve it mathematically or do it vectorially like we did it in the above case, the answer you will get is 2 at an angle pi by 2, which is 2 angle 90, which is 2 2j. That is the D option. Okay, so the answer to these two questions is 1 watt and 2j amperes. Okay, fine. I don't think there will be any doubts in this question, but are there any doubts from anyone?
No, sir.
Okay, fine. So let us take this next set of questions. Okay, so GATE 2011 technical questions 48 and 49. They are common data questions. The input voltage given to the converter is VI 100 angle root 2 sine 100 pi t. Okay, the current drawn by the converter is having harmonics in it. So the fundamental component of the voltage is 100 pi t. Omega is given as 100 pi, which means frequency is 50 hertz. 100 pi divided by 2 pi. So the current has a fundamental component of 10 root 2 of 100 pi t, 5 root 2 of third harmonic 300 pi t, and 2 root 2 amplitude of fifth harmonic 500 pi t. Okay, so now we have to calculate what is the input power factor of the converter and what is the active power drawn by the converter. Okay, so before we begin solving this question, let us understand what is the power factor and how it is how it is represented in terms of harmonics and everything. So the first metric wherever harmonics are involved in the uh, power electronics or power systems, it is measured by a term called total harmonic distortion. So it is a common measurement of level of harmonic distortion present in power system. So THD can be related to either current harmonic or voltage harmonics. So in the question, it is given as current contains harmonics. So in this question, we'll have it in terms of current harmonics. Voltage is free of any harmonics. It is defined as a ratio of RMS value of all harmonic components to RMS value of the fundamental component. Okay, so basically it is the ratio of all other of the RMS values of the all the harmonic components, including the fundamental, to the fundamental component. Mathematically, it is represented as THD under root VRMS of the waveform upon V fundamental raised to the whole square minus 1. I mean, you can expand this and understand what it means exactly. Okay, so basically if you expand this, take it on the right side and see, it basically means it is the RMS value of the remaining harmonics apart from fundamental upon the fundamental. Okay, so where VOR is the total RMS value of the harmonic. Don't get confused. I have used V here. We will be talking about current harmonics only. This is just to explain you the concept. Okay, so VOR is the total RMS value and VO1 is the fundamental RMS value. Now there is another concept called as distortion factor. It is the ratio of fundamental component to the RMS value of the waveform. Okay, so distortion factor is fundamental component upon total RMS content. Okay, so this total RMS content contains all the harmonics, fundamental, third, fifth, seventh, if they exist, and so on, RMS value of those, and VO1 is only the fundamental amplitude. And the relationship between distortion factor and total harmonic distortion is THD is equal to under root 1 upon df square minus 1. Okay, based on these two formulas which I told. In different books there can be different notations. The definition which I have followed is one such definition, but you can remember as any book which you refer, but this is what I follow. Okay, so THD and distortion factor are related like this, and these are their definitions. Now as third and fifth harmonic voltages are 0, basically only fundamental voltages is given in the question, their respective powers are 0. Okay, so basically if you say power of third harmonic, which is V3 into I3, is equal to 0. If you say power of the fifth harmonic, V5 into I5, is equal to 0. Even though I3 and I5 exist, there is no V3 and V5, therefore they are 0. And if you go by the literal definition of power, if you just simply multiply V and I, you will come to know that only the active power is caused by this first two components. If you multiply this V with this I, you will say the multiplication of this V with the second and the third term will result in an oscillating power whose average value will be 0. So the real power which we talk here is the average power which we talk, because this is a single phase supply. Okay, in single phase there are two components. When you multiply two single phase supplies, there is something called as an oscillating power and there is something called as active power. So when you take average, the oscillating power comes out to be 0. I leave that exercise to you because that is an important concept and you should understand that on your own. Okay, so P3 and P5 are 0 and multiplication of V with this remaining harmonic contents is also 0. So only component that contributes to active power is the fundamental component. So let us calculate the power factor here. So power factor is the product of displacement factor and distortion power factor. So I didn't define displacement factor earlier. It is fairly simple. Displacement factor is simply cos phi between the fundamental components of the given voltage and current. So here the displacement between fundamental voltage and current is pi by 3. So cos pi by 3 is 0.5. Okay. Distortion factor is I fundamental upon I RMS. Okay, so I RMS of the total. So if you take RMS value of this current entire, and if you divide the fundamental component by the total RMS value of this, you will get distortion factor as 0.88. Okay, so basically that you will calculate by 10 by root 2 upon 10 by root 2 square under root 10 by root 2 square plus 5 into root 2 whole square plus 2 root 2 whole square. Take the entire under root and divide it by that. So distortion factor calculated by this formula comes out to be 0.88, and power factor is basically multiplication of both 0.5 into 0.88, that is 0.44. That is the B option. Okay. Now active power drawn, like I said, if you multiply this V and I with that can be the actual way, literal way, V into I, and find which, and when you multiply V and I and take the average of that, you should see what component remains there. You will find out that only the fundamental component remains for this question. So V into I will be 100 into 10, basically VRMS into IRMS, 100 into 10 into cos of phi, that is 0.5, that is equal to 500 watts. Okay, so both options will be B. So any doubts in this question?
No, sir.
Hello.
Yeah.
Sir, here we can also do that, na, like active power upon apparent power.
Yeah, that is also the approach.
Okay.
Yeah, you can also do that. There are like multiple ways you can understand this concept. Depending on the question in the exam, you find which is suitable to you or which you are comfortable with. I have just shown one such way. But these questions are very frequent in the GATE exam. If not, they don't. If not, they come everywhere. But every alternate year, similar questions are asked in the question paper by twisting them. Like not just for networks, they are asked for inverters also. Third harmonic, fifth harmonic. They'll now this question was for single phase. They can ask you for three phase also. They can go in triple N harmonics in three phase whether triple N harmonics are there. I'm just taking some names, although I'm not showing any content for that. But I will suggest that you focus on this harmonic content and power factor related concepts importantly, because this THD and distortion factor are pretty much interesting topics for the question paper setters, because in rectifiers, diode bridge rectifier and controlled thyristors and all that topics, they will ask you the questions related to source side power factor, source side displacement factor, source side distortion factor. All these questions are very frequent in GATE exam. So you make sure you understand these concepts well. I have just shown the basics of this concept, which was the intention here. But you try to apply this THD and distortion factor to the questions related to rectifiers, where source current drawn is a square wave, which is phase shifted by alpha and all that. I've taken those questions in the previous run of this NPTEL course. You can see it on NPTEL portal also. But yeah, that was the intention here. Fine. So this displacement, distortion, and power factor and active power drawn, these concepts are important from power electronics and power systems perspective. Okay, from inverters and rectifiers topic. Fine. So these were the 4 questions I planned for today. Any doubts?
Yes, sir.
Yeah.
Sir, in last sessions, you asked us to learn those eigenvectors and that topic through graphic approach, but I couldn't get any content which I could understand from internet. Can you suggest something?
For eigenvectors, like there is some little bit advanced and little bit introductory also. So like there's one professor called Gilbert Strand from MIT. So he is uh, Gilbert Strand. I hope I'm spelling it right. Gilbert Strand. His lectures of linear algebra are the best. Everybody follows that here in IIT for linear for eigenvalues and eigenvectors. And I had there is a free of cost course on Coursera. Like it's for machine learning, but they teach you linear algebra from basics. You need not go into the machine learning part, but mathematics mathematics of machine learning is the course on Coursera. Okay, so they will not teach you machine learning there. They'll teach you the mathematics that is required for machine learning. That is where it's a 5 to 10 minutes video in this course, mathematics of machine learning. There you will understand the physical meaning of eigenvalues, all the vector algebra that is there, of the Taylor series and all that. And that will lay the foundation for all the gate subjects what you do, the advanced concept. If you are going to give EAC, or if you are going to learn any control systems when you go for higher education in IITs or IISc. Okay, so if you understand it that way, this linear algebra rather than formula based, it will be beneficial. So this Gilbert-Stranz lectures will be little bit tough. If you want little bit easier version, then that free of cost videos are there on mathematics for machine learning on Coursera. It will take hardly 20 minutes, 5 minutes, 4 or 5 videos are there. So in that you can understand eigenvalues and eigenvectors in this.
Okay, thank you, sir.
Yeah. Okay. Thanks. Okay. Thanks a lot. Thank you guys.
Welcome, sir.